Deep inside your old electronics lies a treasure more valuable than ore. Today, scientists are turning cheese byproducts into gold sponges, and ancient mints are becoming high-tech treasure hunters. The contrast is stark. From a mountain of toxic waste to a single bar of pure wealth. Urban mining protects our planet, recovering resources without digging new scars into the earth. These properties made gold irreplaceable for computer chips, motherboards, and every electronic device that would follow. Traditional gold mining extracts about 5 grams per ton of ore, but a ton of old circuit boards contains up to 500 grams. This is the alchemical journey of mining our own trash.
Thousands of tons are discarded every day. Truck after truck is filled to capacity.
Arrival at the urban mining facility.
Every kilogram is accounted for. The raw material is ready for processing.
Local centers aggregate the digital debris.
Workers separate the valuable computing power from simple appliances.
Skilled workers line the dismantling zone, removing hazardous components that machines cannot handle.
But first, we must neutralize the fire risks hidden on the board.
Aluminum heat sinks are bulky and low value, so they are stripped for standard recycling.
Precision engineering, brilliantly realized. The gold standard in performance.
Heavy machinery takes over, bridging the gap between human waste and industrial recovery.
The first step is feeding the beast, beginning a process of total destruction. Before the shredders can eat, the material must be prepared by hand. Lithium batteries are explosive if shredded, so they are diverted to a separate stream.
The empty steel case is sent to standard metal recycling. Its job done.
Only the circuit board remains, joining a river of technology heading for destruction.
The boards climb the final ascent to the mechanical shredder.
There is no turning back. The boards fall into the primary crusher.
Massive torque tears the fiberglass and copper apart in an instant. Inside the shredder, complex engineering is instantly reduced to jagged confetti.
The output is a coarse mixture of plastic, copper, and steel chunks.
Powerful overhead magnets defy gravity, plucking steel waste from the stream. Iron is removed early, leaving behind the valuable non-ferrous metals. To unlock the gold, the material must be pulverized into a fine sand.
Advanced filtration systems ensure the factory air remains safe and clean.
The result is a uniform powder, a homogenized mix of plastic and metal.
An eddy current separator repels aluminum, launching it away from the copper.
Recovered aluminum is a useful byproduct, but not the main prize.
Air tables use vibration and gravity to float the plastic away. The waste plastic is blown aside, leaving the heavy metals behind. What remains is the concentrate, a heavy sand rich in copper and gold.
The data confirms high concentrations of copper, gold, and silver.
Mixed with silica flux to aid the melting process. A crane lifts the charge, preparing to feed the smelting furnace.
Temperatures inside the furnace reach over 1200 degrees Celsius.
The solid sand is instantly transformed into a pool of liquid magma.
Impurities lighter than metal float to the surface, forming a crust called slag.
This waste rock is poured off, leaving the precious metal mix behind. What remains is blister copper, a molten collector absorbing every ounce of gold.
The furnace tilts again, casting the liquid fire into heavy plates called anodes.
These molds shape the metal into positive electrodes, critical for the next stage. Jets of water freeze the metal, locking the gold inside a solid copper block.
The result is an anode, a heavy, impure slab containing copper and precious metals.
To extract the gold, we must destroy the copper in a chemical bath.
Welcome to the tank house, a massive cathedral of electrochemistry.
Days later, the copper is removed, now 99.99% pure and gold-free. We filter the solution. The brown sand that remains is pure gold.
Distilled water washes away the final chemical impurities, leaving only the precipitate behind.
Heat drives off the moisture, transforming the wet sludge into a fine, matte yellow sand.
The dry powder is carefully transferred to a graphite crucible, ready to return to metal. Induction coils generate intense heat, liquefying the powder in mere seconds. Magnetic fields stir the molten pool, ensuring a homogeneous, mirror-like consistency. It flows like heavy syrup, filling the void with pure potential wealth.
As it cools, the crystal structure locks into place, solidifying into a bullion bar. Emerging from the water, it is heavy, cold, and chemically pure.
Polishing removes the casting skin, revealing the iconic, lustrous shine.
Precision is paramount. Every gram is accounted for on certified scales.
The contrast is stark, from a mountain of toxic waste to a single bar of pure wealth.
Urban mining protects our planet, recovering resources without digging new scars into the earth.